Hello everyone. Growth beyond all bounds for a billion years on our finite planet. In the wealthy societies of Europe, not everyone sees progress, prosperity and growth as desirable and beneficial. Poorer societies cannot afford such scruples. But as the world's demand for energy and raw materials surges, and as we edge ever closer to the planetary limits, we are clearly putting at risk both biosphere and climate. Are we nearing a turning point? And if so, what direction should we take? Influential voices and interests argue that economic growth must slow down or even reverse for the sake of humanity and of nature, and also in order to overcome capitalism. Before evaluating this provocative position, I'd like to take a step back, way back to the very beginning of life. For this deep history holds a multitude of lessons on growth, scarcity, and resolving the conflict between them. So in this video, I'd like to summarize some fascinating recent research on crucial turning points in the history of life. These show that life has always faced resource limitations, but has found path to growth every time. This deep history also reveals different kinds of growth. Extensive growth, more for more, that was catastrophically destructive at times, but also intensive growth, more from less, that was astonishingly creative, overcoming resource limitations in surprising ways. This often overlooked possibility of creative growth is of particular relevance today, as it clearly suggests a viable direction for our wealthy societies to take. Life likely began more than 4 billion years ago along the deep sea trenches, where water and gases emerged and still emerge through natural vents from the Earth's hot interior. Within the porous rock of these deep sea vents, basic biomolecules such as amino acids and lipids formed spontaneously through mere chemistry before any biology. Primordial life invented enzymes and cell walls to enrich this molecular soup, but it was trapped in the rock pores, depending for its biomass on the gushing flow of geological gases, carbon dioxide, CO2, and hydrogen, H2. Around 3,800 million years ago, something remarkable occurred. Two distinct groups of microbes, bacteria and archaea, escaped their rocky prisons and ventured into the surrounding waters. Some ancient survivors still thrive today in the extreme heat of deep sea vents, affording us a glimpse into life's very beginnings. The freed microbes comparatively quickly discovered new ways of harvesting energy in the metal-rich waters surrounding the deep-sea vents, especially through the reduction of sulfur and sulfate. The next 1,000 million years until the end of the Archean eon saw many further innovations, including fermentation, the fixation of nitrogen from the air, and respiration, that is, the combustion of biomass with oxygen, what we do. Of particular importance was the photosynthesis of biomolecules with the help of light. Initially just a weak heat radiation from the deep sea vents, but later the far more energetic sunlight. So to recap, 1.5 billion years of creative growth formed an oceanic community of microbes tapping diverse energy sources and complementing each other's metabolisms. The next major transformation came with the rise of cyanobacteria, more commonly known as blue-green algae. These tiny pioneers harvested sunlight and atmospheric carbon dioxide, CO2, releasing oxygen, O2, as a waste product. At first, the bacterial oxygen reacted with the dissolved iron in the oceans, forming rust deposits in inconceivable amounts, hundreds of thousands of billions of tons, the very ones we mine for iron ore today. After the dissolved iron was depleted, The bacterial oxygen accumulated in the atmosphere where it decomposed methane, CH4, a greenhouse gas that had kept the planet warm. As the sun was much weaker back then, losing this greenhouse effect plunged the planet into a global ice age, with glaciers deep in the tropics almost to the equator, a so-called snowball Earth. But this was not the worst of it. While the cyanobacteria still thrived, they not only raised the global primary productivity of the biosphere to unprecedented levels, perhaps 200% the modern level, but also increased oxygen concentrations some thousandfold. As oxygen is highly toxic, the global boom ended in total collapse. 99% of the biosphere died off, and global primary productivity fell to perhaps 2% of modern levels. So the cyanobacteria were a truly apocalyptic case of destructive growth. The recovery from this catastrophe took another 1,000 million years until the end of the Proterozoic eon. These were epochs of extreme scarcity, oceans dominated by sulfur bacteria, and oxygen available only in some shallow waters. However, the long period of starvation also produced many decisive innovations. Protective mechanisms against oxygen allowed energy-efficient metabolisms with respiration. Microbes of different kinds proliferated promiscuously in thick mats on the seafloor, developing many forms of cooperation and symbiosis. More complex and capable cells, eukaryotic cells, formed when some archaeans began to host symbiotic bacteria inside their cell bodies. These newly potent cells banded together in larger numbers, forming cell tissues with collective functions. And finally, these multicellular structures developed the body axis and began to move about in order to graze the bacterial mats more efficiently. Creative growth took another leap in the Ediacaran epoch. The fossil record reveals no dramatic geological upheavals, but something far more subtle and profound: purposeful behavior. For the ancient silt reveals increasing bioturbation, that is, traces, tracks, burrows, ducts and tunnels, formed by creatures actively shaping their environments. And thus a gentle and peaceful world of sessile filter feeders was overturned by the increasingly purposeful behavior of moving newcomers. To survive in this suddenly volatile and uncertain world, these creatures developed eyes to see, claws to hunt, and armor to defend. The biological arms race led to many life forms that still exist today, as well as to an explosion of fossil remains for us to find. The increasingly harsh competition in the Cambrian oceans eventually drove life onto dry land. First came lichens, fungi, mosses and ferns, later also arthropods and insects. Once again, creative growth had crossed a new frontier. Our final chapter was written by the fast-growing forests of the Carboniferous period, which piled up wet peat soils in the vast lowlands of the continents of that time. The unchecked growth of these peat-producing forests over some 50 million years proved destructive in many ways. Most importantly, it deprived the biosphere of a large part of the Earth's carbon, as the peat turned into the enormous coal deposits that we mine today. Further, by removing the greenhouse gas carbon dioxide from the atmosphere, the ever-growing forests repeatedly triggered prolonged ice ages. Lastly, the forest raised atmospheric oxygen to 30%, well above modern levels, allowing wildfires to devastate entire continents. On the plus side, the oxygen benefited arthropods and insects, which grew to respectable size at the time, for life had learned to tolerate even high levels of oxygen. So what? You may well ask. can these chapters of Earth history teach us today? Firstly, life is growth through innovation, and innovation can overcome all bounds. It was innovation that let microbes detach from the rock pores, an innovation that transformed bacterial mats into complex communities of predator and prey. Secondly, the development of life has been accelerating, as becomes really clear on this long time axis. The reason is simply that innovation tends to expand opportunities for further innovation. A first decisive acceleration was the invention of purposeful behavior in the Ediacaran, and one of the last was human language, which allowed innovation and know-how to be shared between individuals and generations. So from this historical perspective, humanity and civilization are neither more nor less than further stages in the development of life. Thirdly, growth can be destructive when it is merely extensive, that is, when it tries to gain more for more. The cyanobacteria and the coal forests make for horrific cautionary tales. However, growth can also be creative when it is intensive, that is, when it achieves more with less, often by balancing competition with cooperation. Creative growth can colonize new territories by forming complex ecologies. As strikingly illustrated by the bacteria and archaea in the Archean eon, by the predator and prey communities in the Ediacaran and Cambrian, as well as by farming and husbandry in the Neolithic, or by today's economies with free trade and division of labor. So these chapters of Earth history teach us that environmental resources have always been limited and that innovation has always been necessary. Every point in the development of life has been a turning point, large or small. Surely already the Ice Age shamans warned, quite rightly, that the great mammoth herds would soon be gone. The most important lesson, however, is that slower growth leads inevitably and invariably to a dead end or even extinction. The slow-growing microbes of the Archean eon are still with us today, but in the digestive tracts of cockroaches. So our modern responsibility and duty is to continue the history of life with new growth through new innovation. We must not only allow creative growth, more from less, but accelerate it so that it can displace and replace destructive growth. To be a bit more specific, we must generate more energy and prosperity from fewer raw materials and replace the fossil fuel economy with superior alternatives. Less growth would be dangerous and counterproductive, for our free societies would simply relinquish to fossil dictatorships the field and the future. So history's verdict is clear. Life moves forward, and so must we. Thank you for listening.